Hello, Mrs. Greathouse here. Today we are working on section 2.3 in chemistry, which is all about elements and compounds. An element is the simplest form of matter that has a unique set of properties. Okay, an element cannot be broken down into anything smaller and still be an element. Think of simple and elementary school. Elementary school was simple. An element is simple. Okay, a compound is a substance that contains two or more elements in a chemically combined fixed proportion. Okay, so compounds are going to be when we bring two elements together, like table salt, sodium chloride, or water, H2O, two hydrogens and an oxygen. Okay, to remember compound, think of compound word. Okay, two words together that become one word, like backpack. Okay, and here's our key point about elements and compounds. Compounds can be broken down into simpler substances by chemical means, but elements cannot. Okay, if we talk about salt, sodium and chloride, we could break our salt down into sodium and chloride. But if we look at an element like gold, okay, we can't break that down any farther and still have it be gold. Okay, we talked about physical changes earlier in this chapter, okay, where we could change a substance but it would remain the same no matter how small we cut it up. A chemical change is different. Chemical change is a change that produces matter with a different composition than the original matter. So we're going to have changes going on. It's not going to remain the same. Okay, our example here is when we heat table sugar. If you've ever tried this, you probably made a sticky mess in the bottom of the pan. Okay, but you can see that we would start with our white sugar here. Okay, so that's going to be C6H12O6. Okay, but then when we burn it, we end up with just carbon. Okay, like coal, it's black. There's been a change, and all our hydrogens and oxygens have gone off into the atmosphere as water. This slide shows us that reaction and also goes a little bit farther. Okay, here's our sugar breaking down into carbon and water. It shows that we could break the water down with electricity and hydrolysis into the hydrogen and oxygen. Now we have broken sugar down into all of its three elements, carbon, hydrogen, and oxygen. In most cases, in general, the properties of compounds are very different from those of their component elements. When we look at salt and the sodium and the chloride that make it up, you see a huge change. So chlorine all by itself is put into swimming pools to kill the bacteria. Okay, if you drank it or breathed in the chlorine gas, it would be poison to you. Okay, sodium, as you see here in the sodium street lamp, is usually kept under oil to prevent it from reacting with the air. Okay, if we had a chunk of sodium and poured water on it, it would be a very violent explosion. okay? But when we put sodium and chloride together to make salt, we get a compound that is safe enough for you to eat, okay? So the characteristics of a compound can be very different from the elements that make them up. And here's another key point. If the composition of a material is fixed, the material is a substance. If the composition of a material may vary, the material is a mixture. So some examples of a substance are going to be our compounds like sugar, salt, water, and carbon dioxide. Okay, and we already have good examples of mixtures. Okay, tossed salad, Lucky Charms, trail mix, chicken noodle soup. Okay, this chart is in your book on page 50. I find it very helpful. Okay, it is going to help us determine if matter is an element, a compound, a homogeneous mixture, or a heterogeneous mixture. Okay, so if we take our matter and think about it, if our matter is of definite composition or homogeneous, okay, it can be considered a substance. From there, we can branch out to determine, is it a compound, okay, is it made of more than one element, or is it just a single element? Okay, if we know that our matter is a mixture of substances, okay, we go this way down the tree. And from there we determine if it's a uniform or homogeneous mixture like stainless steel, or if it is a heterogeneous mixture, okay, like granite. Okay, note this arrow here. Okay, if we have a mixture and it can be separated physically by distillation or filtration, then we're going to end up with a substance. Okay, and this green arrow down here tells us that if we can separate a compound chemically, we are going to find elements. Okay, next key point. Chemists use chemical symbols to represent elements and chemical formulas to represent compounds. Okay, these are our letters that are up on the periodic table. Okay, earlier centuries they used a lot more complicated symbols. They almost drew a picture to represent different compounds and elements. Okay, but now we just use a letter or two. Okay, each element is represented by a 1 or 2 letter chemical symbols. Okay, some of these we are very familiar with. You know that carbon is C and hydrogen is H. Okay, some of these come from Latin names, and they're usually the ones that don't coordinate with the first couple letters of the name of the element. For example, sodium is Na. That comes from its Latin name natrium. Okay, the gold is Au. It comes from its Latin name aurium. When we write the name of a compound with chemical symbols, we would simply combine two. Like salt would be sodium chloride or capital Na, capital Cl. Okay, note that when we write our chemical symbols, it's always only the first letter that is capitalized. Okay, that's it for today. Write a question for me, do your summary, and we'll see you in class tomorrow. Thank you.